Hello everyone. Today we're looking at geometric reflections. To start things off, a figure is reflected over a line. Many of the things we'll be talking about today deal with lines of coordinate grids, defined axes if you will, such as the x-axis, the y-axis, the positive x-diagonal, and the negative x-diagonal. But you will also see problems like reflecting over the line y equals 7 or x equals 12. So we're going to stick to lines for our definitions. Specifically, the lines, we're going to call them lines of reflection. Now, as far as the fundamentals, our x-axis and our y-axis, if we flip points over the x-axis, we're going to be changing the sign on the y-coordinate. Whereas if we flip things over the y-axis, we're going to change the sign over on the x-coordinate. So whatever axis we're working with, we're going to change the opposing sign. How does this look applied? We want to reflect the triangle here over the x-axis. As such, since we're dealing with the x-axis, that means we're going to be working with our y-coordinates by changing those signs. So our first point A of -3, 4 would become -3, -4. Our B of 5, 0 would become 5, 0 still, because 0 is neither positive nor negative. And C of -4, 1 would become -4, -1. Let's go ahead and plot those out. And we'll pretend all of our dots are nice and straight. So that's our 5, 0. Then -3, -1, 2, 3, 4. And -4, -1. Connect those dots to give us our reflected triangle, reflected over the x-axis. Example 2, we're going to flip this triangle over the y-axis. So reflecting over the y-axis, that means we're changing the signs on the x-coordinates, such that our A value of -6, 2 would become +6, 2. Our B value of 2, 4 would become -2, 4. Our C value of -2, -1 would become +2, -1. Plot them out. 6, 2, -2 and 4. And then 2, -1. Connect our dots to give us our reflected y-axis triangle. So general properties. Pre-images and images, this is the same terminology that we're using back in ratios. Pre-image and the actual image are going to be congruent to each other, which means that the corresponding angles themselves will be congruent to each other, and the corresponding sides will be congruent to each other. This all plays into the idea of isometry, which we're going to see a lot of moving forward with this unit. So reflections are a form of isometry. Let's take a look at some practice problems. Practice number 1. We want to graph and label the pre-image, already done, in red, and reflect it over the y-axis. Now, reflecting over the y-axis means we're going to manipulate the x-coordinates. By manipulate, I mean flip the sign. So my A coordinate of 3, 4 will become -3, 4. My B of 0, 5 will still stay at 0, 5, because once more, 0 is neither positive nor negative. And my c of 1, 1 will become negative 1, comma 1. Plot them out, such that we get negative 3, 4, zero, 5, and negative 1, 1. Connect our dots. We get our reflected y-axis shape. Practice number 2. We're working with the reflecting over the x-axis, which means we're looking at our y values to manipulate, such that our e point goes from negative 3, comma negative 1 to negative 3, comma 1. The f point goes from 2, negative 4 to 2, comma 4. Our g point goes from negative 5, comma 6 to negative 5, comma negative 6 to negative 5, comma 6. Plot those in. So negative 3, positive 1, 2, positive 4, and negative 5, positive 6, right there. Connect our dots to give us our triangle. Pretend those all are straight and connect. Now, what happens if we're going to reflect things over diagonals? When we reflect over diagonals, we have to change how we're thinking things. If we reflect over the positive diagonal, y equals x, then we're going to swap the positions of our x and our y coordinates, such that if we had the coordinates of originally of 5, 12, they would become 12, 5. Just a straight up swap. But if we were to use reflect over the negative diagonal, we still have our x and y's transposing, swapping positions, but now we also have them swapping signs. Such that if we had 5, 12, that would become negative 12, negative 5. So graph ABC across the line y equals x. So that's going to be our positive diagonal, which I'm going to put here in purple. You don't need to do this yourself, but I'm just using it as a reminder placeholder. So positive diagonal means I'm going to transpose my x-coordinate and my y-coordinate. So my a value reflected will be negative 5, 12. B be negative 1, 4. And C would be negative 7, 6. So we'll go ahead and put those in. Wrong. Negative 5 up 2, 2, 3, 4, 5, and 2. Negative 1, 1, 2, 3, 4, and negative 7 up 6, 4, 5, 6 to give us our triangle. Example 4. Similar sort of thing, except now we're looking at it in terms of our negative diagonal. Such that we are going to not only transpose our coordinates, we're also going to change the sign on both of them. Such that for A, that would become 1, 3. B would become 5, 0. And C would become 5, 7. Go ahead and put those points in. Five, and then 7. Connect our dots. Gives our reflected shape. Now suppose that we wanted to reflect across a line other than the x-axis or the y-axis. So far, we've been reflecting over essentially the origin values. The y equals 0, x equals 0, or the positive and negative diagonals that have more or less an origin point to their values. But if our line of reflection shifts, if it's going to be something other than an axis, then what we have are essentially 2 steps to do. Step 1, count the shift. Figure out how far from the line of reflection our points are along the corresponding axis rules. Step 2, reverse shift. Once we figure out how far we've shifted in one direction to give us the original values for the pre-image, we're going to shift in the opposite direction to find the corresponding reflected values. Make a little more sense when we work a problem. Now, there are going to be I'm going to use a few colors here. The only color that would be needed for like turning your work, answers on a test, answers on a assignment will be in blue. Everything else is there to assist you, to color code guides as you will. So we're going to graph triangle ABC across the line x equals 1. So I'm going to draw in x equals 1. It's a vertical line. Since it's a vertical line that's parallel to our y-axis, we're going to treat it kind of like our y-axis rules. And the y-axis rules say that what we're changing are going to be the x coordinates. So we're not changing the value directly, we're not changing the sign directly, but that's going to be what changes in our process. My next step is I'm going to count the shift. With respect to each of these x values, I want to see how far are they from my line of reflection of x equals 1. Such that the a value, for instance, is 2 units away, or 2 units to the right of our line of reflection. Our b value is 4 units, and our c value is 6 units. Now I'm going to reverse shift. My y coordinates aren't going to change, my x coordinates are. Because I know that my a value is 2 units to the right of my line, I'm going to keep the same y unit, but go 2 units to the left from my line of reflection. So 1, 2 units. For b, I went 4 units to the right, so now I'm going to go 4 units to the left. 1, 2, 3, 4. For C, that's 6 units to the right, so I'm going to go 6 units to the left. 1, 2, 3, 4, 5, and 6. To give me my coordinates. Connect my dots. And there's my reflected triangle over the line x equals 1. At this point, we can simply look graphically to see what coordinates each of these are. Or if you prefer to do it without the graph, once you find the distances, you're essentially going to subtract each distance from our x equals 1, and that'll give us our corresponding x coordinate. So 3, 3 will become -1, 3. 5, 7 will become -3, 7. 7, 1 will become -5, 1. Graph ABC across the line y equals -2. Well, -2 is going to be down here. I want to see how far each of my points are from y equals -2. Oh, sorry, skipped a step. Because I'm doing my y of -2, this is parallel to my x-axis. So I'm going to use x-axis rules, which means I'm changing my y coordinates here. So I want to see how far each of these y coordinates are from my line of reflection. So my A value, that's 7 units above, whereas my B and my C are both 3 units above. Which means then, for my reverse shift, my reflected A value is going to be 7 units below my line of reflection. So 1, 2, 3, 4, 5, 6, 7-ish. Whereas my B and my C are going to be 3 units below. So 1, 2, 3, and 1, 2, 3. Put in my blue dots. Connect them up. And we have that our new values are -1, -9. Our 2, 1 became 2, -5. And my C became -5, -5. Now, folks, if you have questions on these, please ask. Otherwise, please work on your assignment.